video.
So what exactly are we running today?
We're doing sorting.
Oh, kind of like what we're doing with the big Latin thing.
No, that one is kind of on that one. That's a figure.
You have a default image? Yes, I gave it a default image. It creates an error, because it has to have pulled something. Even if you're pulling from nothing, really, you can pull from like a little text, like, and it'll be fine. But as long as you're pulling from something. Oh, you can set it to the default image thing. Yeah. I just set it to image. Change it and start prompt for. Crap. Oh, I'm just gonna figure it out.
That picture's gonna kill me.
How do you do that? That's cool.
Hard decision. Hard decision. It's like, just can't decide. I could go. I could just not
It
stay.
would take longer to set up the job.
Do what?
It would take longer to set up another computer to start this one.
Is it shut off? Oh. No wonder you had that look. Where is the rest of your side, Levi? Late people. Late people.
If I feel bad, I'll come in later. I don't want to like ruin the whole day.
It literally, I worried it's a whole different story.
People
just call it.
I don't call like, I get 6 hours or so, but I try not to call more than necessary. I try not to call myself.
And literally, I've done my job for a year and a half. I haven't called in. I got the thing 2 years restart.
Impressive. Not me. I usually like. I try not to, like call in once a month. It's not like I schedule it. Usually it's that maybe every 6 weeks or so. Kind of depends. Usually though, I spend the whole day. It's like probably I don't know, go in around 7 or so. 7:30. Work for 4 hours. They're really chill about it, and it's not like the stakes are super high. Like, oh god, we're gonna be breaking blocks. We don't have enough staff to clients or something.
You guys, the Zoom link is posted on our announcements if you want to connect.
I remember
plugged in here.
I remember using Zoom last semester, and I had to I had to stand by a window just to get a decent internet connection so I can use it.
How come?
Huh?
How come?
I didn't have internet at the time.
Oh, at home?
Yeah.
Oh.
That's the only reason I remember the app.
You can get your exercise.
It was during winter, so I couldn't like go outside because of how cold it was.
Did we look at the calendar last time? I'm thinking that I did not do that with you guys. I did with the other classes. So let's take a look. First of all, today's the 26th, right? You know that the 8th and 9th you have no school. That's fall break. Got that on your calendar, right? Then the other one is October 25th. Do any of you want to register for Check It Out? You want to?
Find out my date, make sure it's clear on the track.
Okay, so Thursday, October 25th is the date. And even though we don't have class that day, you guys are welcome to go ahead and register if you want. My Thursday classes will be, meeting at Check It Out. So we won't have class that day. But since we're a Monday, Wednesday class, it's a little different. But you guys are welcome to go. And I'll just bring up the website. If you want to register real quick, you can. If you know your schedule is going to be flexible enough. Now remember with Check It Out, I just search for Check It Out, and it's usually the first result. That one. And so they don't have, oh, thank you, sir. You should see my 120 class. Oh my God, yesterday, what a mess. I accidentally said you guys should check out Zoom while I'm getting this last person set up. So by the time I got up here, I had drawings all over my screen and everything. And by the end of class, they'd sort of settled down because we were working on Python for the first day, so they were really intense. And then at the end, I said, okay, click here. And somebody just started splatting little purple arrows everywhere I said to click. And I was like, oh, that's really nice. And so before I knew it, I had about 500 little purple arrows. They are very helpful.
Kirsten introduced us that this morning.
Huh?
Like, Kirsten introduced us to that this morning.
Uh-huh.
And it was like, it caused a delay to, like, there's so many arrows.
Yeah, it was really funny. I liked it. So I was really impressed with them. They're a really good class. And there's a bunch of them that are just really good explorers like that. So they all just took off and were doing everything. Okay, so check it out. OTC, of course, thinks it's important enough for you guys to go to this that they're willing to pick up the tab for you. So don't register unless you're pretty sure you'll be able to go.
That's why I'm holding off until I.
Yeah, nobody will come punish you or anything.
I know,
But it's better to wait if you can. Yeah, but remember, you can come and go. So it's not anything like you have to be there the whole day just because you registered. Now, when we get to the end of registration, they'll let us print off a tentative schedule.
We say I put out my schedule will be 100% open that day.
Uh-huh.
Can I email you and ask you that?
Sure, and then you can get registered then. So right now, the tentative schedule is 7 to 8 in the morning is registration and the free breakfast. And then 8 to 9 is the welcome and keynote speaker. And the last time I went to the breakfast, the welcome and keynote speaker was in the same room where they served the breakfast. So I don't know if that will be the same or not. And then 9:30 is when the breakout sessions start. So in the past, all the breakout sessions have been IT, so networking, PC maintenance type things. This year, they're supposed to have a separate track that's programming. So there's supposed to be more sessions that'll be interesting to us instead of all this network security, which are super interesting also. But it'd be nice to have some software development tracks. So the sessions go from like 9:30 in the morning until 5:30 at night. They're each about an hour, hour and a half long. You can come and go as you like. If you see a session that you're interested in, you could come just for that. The vendor fair will be open all day. And in the vendor fair is where the companies that are tech related in Springfield will set up a booth. So you guys can walk around and talk to them if you want. You guys hire a lot of software developers? What kind of things do you look for in a software developer that you're going to hire? What would be something you would recommend that I say in an interview? Those kinds of things. They're all pretty open to hearing those kinds of questions. But the big thing is to get their free stuff, right? Because a lot of them have nice flash drives. Didn't have as much free stuff last year, the year before. Because I'm not really interested in job stuff, so I'm super interested in free things. As a teacher, it's just a requirement.
Free things are always nice.
Yeah. Finally, at the end of the day, the closing reception has free food and drinks, and they usually have door prizes. Last year, some people said the door prizes were kind of rigged, so you guys need to go this year and make sure that some students get some door prizes. They said it seemed to be the representatives of the companies that had donated the most money seemed to win all of the door. Was there? Good stuff. Dang, they don't want to just give that away to you guys. But they should, because they want you. Okay, so if you're at the website, click on register. And I would use your OTC email address. For your registration category, choose attendee, and your registration type, choose, come on. Oh, it won't let me have it. Full-time student, non-AITP student chapter. Now I'm already registered, so if I click next, it won't take me the same path as you anyways. So whenever you get done with that first screen, click next. And I will find the email with all the info in it. Too many emails. Did any of you guys go to the capstone presentations last week? No? Dawn. Well, it was on Thursday. And that's the day I had to go home sick, so I missed them. Hang on, I'm not finding her email. There it is. I just went past it. Okay, so after that first screen, your company is going to be OTC and your title is going to be student. I would use your address at home. They don't send mail much, but if they did, then it would get to you. Finally, when you can, click finished adding people. And you should see that screen where it tells you your bill is $30. And you want to enter the code OTC Tech, all in uppercase with a space in between, and click apply, and it should take your balance due down to 0. And then you're ready. OTC. Mm-hmm. And student. And OTC Tech.
All caps?
Yes.
Okay.
All caps with a space in between.
You want your work address now?
Just use your home address.
Oh, man.
I'm trying to keep up. And
You're okay.
You can just hit word now.
Where are you at?
I'm on the second page.
What do you need?
We're just asking for like the company title and everything.
OTC and student.
And that autofill, and then just kind of put it all caps. I'll put my name there. I don't even invite anybody else. this account code is what again?
OTC space tech.
How long, like, it started at, what, 8 in the morning, and how long is it?
It goes until, it says the final breakout sessions start at 5:30. But it usually settles down pretty much before that.
Okay.
The wrap up and closing is supposed to be 5:30 to 6:30.
That's good, that means I wouldn't have to miss my whole day of work if I did that. which is
Yeah.
great.
Go to the end.
I might take
I got to the discount.
OTC space tech, all in uppercase.
Did you say your classes that day, or you're not gonna have
Right,
all day?
right. We'll go to Tech It Out instead.
No database classes?
Right. So they all registered yesterday.
Thursday, right?
Yeah, it's Thursday. So we don't have class. OTC space tech, all in uppercase.
Mhm.
Well, it works. So check and see what you got wrong. It worked for everybody else. OTC space TECH. In uppercase
I'll be there.
with the space in between.
Oh, with the space in between every word?
No, between OTC and tech.
Where did you find this?
Oh, I misunderstood.
Oh, that's
Oh, okay. Yeah, I need to ask off for
Okay, I felt bad about that.
That's okay, you got it now?
When
Is
you
it
said
working?
space, I thought you actually meant like the word space, not an actual space.
Usually. All right. Everybody's getting that done. Are you set? Okay. We're going to look at sorting. And if you go to Canvas, by the way, that Zoom meeting URL should stay the same. I finally got Zoom set to where it doesn't change it all the time. And that's my phone number, my office phone number. So if you're ever having trouble finding it, you could just look up my phone number, and that's kind of the standard for online meeting software like that. Okay, so we are in week 6. If you look at the week 6 module, there is this PowerPoint sorting and searching arrays. That's the one I'm going to be looking at. You don't have to grab it, but if you want to, that's where it is, because it does have some links in it to some sites that we'll take a look at. Sorting and searching array.
So just out of curiosity, what exactly are we to do in the Rebel B assignment?
In the what?
In the Rebel B assignment?
Finish that course.
Okay, that's what I was thinking. I just wasn't too sure.
Yup, pretty straightforward. Okay, so let's talk about sorting and searching. Last time we looked at those array lists, and I showed you the methods that there was a sort method available for array lists. There's also a sort method available to the array class. If you do SQL and bring back data from the database, you could order that data, right? So you could do a sort using SQL. So why do we need to sort? We've already got all these sorts all built in that we could use. Are we really gonna ever have to code a sort from scratch? We will. The reason being, sometimes we might have some really specific sorting requirements for our company, like they want things in a certain way that makes no logical sense at all, other than that's how they want it. Sometimes we just have to do things like that. We could have data that's so huge that all of the built-in sorts are very inefficient and run forever. We might think that we could create a sort routine that would be more efficient. But there's lots of times that we just end up having to create our own algorithm to sort. So efficiency. Efficiency is a big deal, and that might be why we have to create our own sort. And there is that whole class, you know, data structures, and he talks the whole semester about efficient programming and coding efficiently, and sorting is one of their big topics because data structures, sorting is a big deal. And so we always have to be concerned about our program efficiency. And there's this whole theory about how efficient code can be. And the one that I'd like to talk about is Big O. Big O notation is used to describe the performance and complexity of an algorithm. And we can use the Big O notation to kind of get an idea ourselves of how complex our algorithm is. How many resources is it going to take? Think about data here. First of all, we've been in this unit looking at different data structures. I was telling you about that last time. We want to know what kind of data structures are available built in and what we can do, what wheels have already been invented so we don't have to reinvent the wheel. From a science standpoint, some of these algorithms and things are things that you might not talk about unless you go for a 4-year degree. So there may be more things on down the road. And it might be that you don't get an opportunity to do a software project with a lot of data until you're in more advanced classes or out in the field, because we have to use test data here in class, and sometimes we don't have very much of it. But no matter what, it's good for you to think about and understand these basic patterns. So we don't want to overthink it. It's not, you know, rocket science. It's just a pattern. But think about these different patterns that we have. So we have patterns that have already been created for us for storing data and searching through arrays of data or collections of data, sorting those collections. And we refer to all of these different things as data structures. So some of these structures are used for certain purposes and some for other things. But no matter what, knowing a little bit more about these built-in structures is just going to give you more tools for your toolbox so that you know how to handle more problems. So Big O. Big O is the worst case. How bad could it be? Well, it could be pretty bad. So Big O is concerned with figuring out how many resources an algorithm requires. So the first Big O category is constant runtime, or O to 1. And what that's saying is our algorithm contains one comparison. This is a pretty small program, right? So this kind of program you wrote at the beginning of C#1 is A equal to B, and that's it. That's the only comparison going on in that program. We know every time that algorithm runs, it's going to do one comparison. It's a constant runtime. It's not going to all of a sudden take 7 hours to run, because it's still just going to be comparing one element to another. So the constant runtime is referred to as O sub 1 or O to 1. Now a linear runtime is a little different. In a linear runtime, we have some sort of array, and we're going to be comparing the first element in our array to every other element in the array. So for example, this array up here, this would be where this element right here is going to be compared to each of these other array elements. As our array gets bigger, that's going to take longer to process, right? So if we only have these 6 little elements in our array, our runtime is going to be really fast. We're not going to use a lot of resources. But if our array grows to the point where there's 6 million entries, now we're talking about many more resources being required to do that. So with a linear runtime, our resource requirements are directly related to n, which is the number of elements in our array, right? So if I have 1 million elements, it's going to take a lot longer to run than if I have 7. So this is linear. As the array increases in size, so does our runtime. We call this one O on the order of n, or order n. Quadratic. This is the one that happens to us. This is where we have a comparison of every element to every other element in the array. So if we looked at this small array like this, it has 6 entries. With our linear runtime, if I compared this element to every other element, I would be doing 6 comparisons, 5 comparisons. with this quadratic runtime, now I'm going to do 5 comparisons for the first element, 5 comparisons for the second element, 5 comparisons for the third element. So I'm going to explode this out to 25 comparisons just with this little bitty array. So if I increase this array to 12, that would double it, right? So I would be looking at twice as many. If I increase it to 24, twice as many. So every time I increase the size of that array, I'm going to have a quadratic increase in resource requirements. So doubling the array, twice as many resources are going to be required to run this algorithm. Quadruple the array, 4 times as many resources are going to be required. So this is the kind of code that can really reach out and bite us. Because in our test environment, it might look like everything's fine. It's running real fast. We test it, looks great. We go to use it in production in the real world, and now we have 500,000 elements in our array, and it runs for 2 days, and they come talk to you about it. We can't have this. Something's got to change. We can't have it. So we need to be thinking about the big O capability or impact of our code. This one, the quadratic, is O on the order of n squared or order n squared. Every time we increase the size of our array, we're going to have a quadratic increase in our resource requirements. Go, click. So that's just big O in a super nutshell. There are some websites out there that talk about it. There's actually whole textbooks about big O and about being concerned with resource requirements. So let's think about it when we're talking about searching for something. Whenever I have an array of elements or database rows, whatever I'm working with data-wise, I often have to search through those to find a specific entry. So we have to be concerned about performance in searching. A linear search is where I start at the beginning of the array and I have this element I'm looking for, and I compare that to every entry in the array till I find an entry in the array that's equal. And then I've found that element. When I'm doing a linear search, the elements in the array can be in any order, because no matter what, I'm going to look at every single entry to see if it matches the one I'm looking for. So this little animation here shows it. This is actually an animation from the old Java book, but it works. So here we have this array. And in our array, each entry just has an integer. And they're not in any sort of order or anything. We have 20 entries in our array. This first example, we're looking for the number 8. So as we start, we'll compare that to the first element in the array, not equal. So we'll compare it to the second, not equal. And we'll keep looking through every element in the array until we finally find the one that's equal. So in this example of a linear search, my worst case, my big O, would be that I could have 20 comparisons because that's the size of the array. Right? So if I made that array 700, then I would have 700 comparisons. So that's a linear search. So pretty common, really inefficient, but something that we do quite often. Now, the one that's more efficient is a binary search. So a binary search is like the Price is Right. Have you ever seen the Price is Right? Have you ever seen that, it's that one game, the higher lower game, that's what I'm thinking of. So they come out and they've got this prize, a car or whatever, and Drew says, guess how much this car is worth? And they have a range. It's somewhere between $0 and $1,000. So the really smart contestant is going to say what? 500. And if Drew says higher, they're going to be like, oh, let's see, halfway between 500 and 1,000. 750, Drew. And Drew's going to say, no, higher. And then they're going to think, 875, Drew. And he's going to say, no, lower. And that person is going to be able to guess the price of that car within the amount of time that's required because they just did a binary search. They cut it in half and they decided which area they needed to focus on. The really dumb ones, if you've ever seen it, when they're really dumb, they're just like 1, 12, 47, and they never get it. So we have to do that binary search to win the car. So let's look at an animation of this. So with a binary search, our data has to be in order, right? Because we can't split it in half if it's not already sorted. So in this example, again, we have the array with 20 entries. We're looking for the number 8. Our first step is going to be to check the entry right in the middle. We'll see that no, that entry is higher than what we're looking for. So we can eliminate the whole top half of that array. We don't need to look at it anymore. We know the entry we're looking for is not there. So we'll eliminate that top half and split the bottom in half again and say, what about 5? Is it match? No, it's lower. So now we can eliminate all those entries less than or equal to 5, and we'll split in half what's left. We've got 7, not quite equal, but one more step, and we can find our answer. So if we're doing a binary search, we're usually going to see some sort of response in about half of the array size, right? Because that's what we're doing, is kind of break it in half. So with our linear search, our big O was 20. We could potentially look at 20 entries before we had a match. With our binary search, we've cut that down to 10. But we have a little bit of overhead in our code, right? Because our code is a lot more complicated to do this than to do the linear search. Cool, so those are our main search algorithms. And if you got out there on Google and looked, you'd probably find hundreds of others, because you know how us computer people love to reinvent the wheel, even though we're not supposed to. So sorting, how do we get that array in order for that binary search?
Wouldn't you just use the sort property?
No, we just talked about that we would have to write our own sort, because that's what we're doing this time. So you could, but what if that sort was really inefficient and you need to use something else? And you need to be aware that it could be a problem, because if it's only 20 entries, not that big of a deal. But if it's something that's going to run at our company every afternoon, you know, forever, then we got to be really concerned about performance for it. So our first type of sort, and this sort is the kind of sort that a lot of the built-in sort methods use, is a selection sort. So let's see if I can get our video to play. I'm going to max this thing. I'm going to max everything, try and get some audio. Looks like it's pretty high. We don't have to hear this guy too much, but I'd like to be able to hear it a little bit.
In this lesson, we are going to show how the sorting algorithm selection sort works. Its function is to find inside the data structure the minimum element, and when it is found, it will be moved in the first position. Repeat this procedure for the remaining elements, not including the element firstly sorted. The maximum number of comparisons of this algorithm is by multiplying n by n minus 1 divided by 2, where n is the number of the elements. And now we are going to see how the algorithm works with a 3D animation.
Don't worry, you don't have to hear him very good. We don't have too many that involve audio today. Here's our guy. He's going to get this array sorted. He's walking the array, looking for a minimum value. Now you know why in every beginning programming language you had to find the minimum and the maximum. I finally found the minimum, so he's going to swap positions. Yeah, it is.
Yeah, but this is also a person that's doing it on a computer, so.
Yeah, but it shows you how poor the performance is.
Compared to something that could be quicker.
Yes, it's a very, very poorly performing sort. And that's kind of why I like this guy, because he's so annoying and monotonous that you remember it's really, really slow. Really slow. Plus, I taught 3D animation, and so I really value that poor teacher that was teaching these classes trying to learn 3D animation that made this scary looking sort guy.
He looks good inside.
Yeah, his modeling is not so great. I'm not exactly sure what's going on with his eyes. You know, he's kind of concerned about sorting, not actually looking at things. So.
It's like they just didn't feel the people.
Yeah, I don't think he made pupils at all. He's just got like zombie eyes. Someone in the class this morning said they would be having nightmares about it, and I told them that is so right. That's exactly what you want, is to be dreaming about code. Plus, as we watch these sort videos on YouTube, you'll see that anytime you're having trouble sleeping, you can find a bunch of sort videos to watch.
That's an idea.
They'll knock you out. Okay, so he's going to give us our big O numbers here based on that. But we know it was pitifully slow, right? He went through that array over and over and over to get that data in the right order. So that was kind of rough, because he could have done it in a more efficient way. So that was being one of the early sort implementations. Other people agreed with you guys and were like, we got to find a better way. But unfortunately, do what?
Well, didn't you look through the array initially and then kind of mark, where it's at, and then have some sort?
You have 7 million entries in your array. What are you going to mark?
Just about to say, how are you gonna do that?
But no, that's exactly what all these other people are thinking, that are like, I can think of a better algorithm to do that. So this is one. This is the insertion sort, which is a little bit step above that selection sort. Now with an insertion sort, this is the one that we'll do our walkthrough with up here together. But with an insertion sort, I'm going to compare the second element to the first element. Do they need to swap positions? I'll swap them. And I'll compare the third element to the second. Do they need to swap? So anyways, let's look at it. You'll see a little bit more about how it works. So this is the insertion sort. So our first two elements are going to compare and decide if they need to swap positions. They did. So he's happy. He's like, there's nobody less than me in front of me. Now these two are going to compare. They also need to swap. Now she's going to check with him. Do we need to swap positions also? No, they're okay. So now again, we'll see. We didn't need to swap on that one. And they're like, we're in order, we're good, we'll clap, or whatever that weird thing is they do.
I can see how this is going to take forever too.
This is like, I think the dance is making it feel longer, but it looks like it's a little better than.
It's much more efficient, right? Because we haven't gotten to the end of the array yet. With 3D Guy, we were walking from the beginning to the end, beginning to the end, beginning to the end. So here we're just moving. Yeah. And so the Hungarian dancers have a whole series of sort videos on YouTube if you want to see them do more.
If we want to see them.
Yeah, you can find them doing all sorts of different sorts. I just didn't know that Hungarian men wore white skirts too. It's cute.
I just realized there's a few men there. Pretty good.
There's half of them are
They're
men.
rocking the skirts.
Yeah, they are. The women have the aprons because they've got to do all the work. But
What I've noticed in their doing is it doesn't go all the way, like it only starts going all the way back if it swaps,
right, it just keeps checking. Do we need to swap? Do we need to swap? And when it finds a spot, it doesn't need to. Mhm.
Now 6 is going to move, and then they'll be done. Yeah, that is a lot quicker than.
Once it hits once that 6 hits the 5 there, to stop.
They just kind of shuffle.
Yeah, now in our code, we would still have to check that 8 and 9, but they don't. They just get so excited. They just, clap and they start dancing. They're like happy. So now they've all got their partners. They can dance. And in this video, they actually dance for a really long time, so we're going to make them stop. But they're awesome dancers. So you can find that. Okay, so that's a selection sort. So the selection sort gets it done a little bit better, but still not super efficient, is it? Those dancers are just about ready to walk off. So what about a merge sort? A merge sort is almost like a binary search. With a merge sort, we're going to split our array in half and sort the two halves. Now, are we going to use a selection sort or an insertion sort to sort those two halves? Probably some other kind of sort. But then with our merge, we're going to merge them back together. And so a merge sort can be a lot more efficient. 3D guy here, you'll see how much faster he is. He's just so good. You got to love him.
But he's just so dead.
He is.
He's soulless.
If they're gonna make it hilarious, they should do something really hilarious. Like have Shrek sort it out for us. I would watch that.
We'll have to see what we can find because I found these a couple years ago. There might be new ones. But I was busy in my 3D animation class. I was like, I want a 3D animation of sorting.
Well, I have to admit that someone to actually go through the lengths of trying to teach with this animation. I give them credit, but they could have
He obviously got sick of working on his model.
You're like, yeah, I'll leave it alone. If he goes out.
Okay, so he's going to split his array in half. And then he's going to start splitting even further. He's updated these videos because the first two don't go up over the table and they used to. So now that first half is in order. He's going to carefully put it back together. Now he's going to sort the other half.
This is a lot faster.
Uh-huh.
Yeah, this is.
Lots faster.
I wonder if he modeled it, that guy after himself. I almost got it done.
Now he's about ready to do a merge, and watch as he's merging, because a merge algorithm is also something that's really common that we don't get a lot of opportunity to do in school. But with a merge, we're looking at two inputs, and as we read them, we're going to decide what order they need to be placed in.
So you don't merge it back together, break it apart again.
No, he's just putting it back in the right order as it's being merged. Yes, the two inputs to see, you know, does this one go first or does this one go first? Yeah.
Instead of
That
taking
was a
5
lot
minutes,
less painful.
instead of taking
It
5
is, and I-
minutes, it's like a step 2.
Watch these guys in the Java class, but I don't like them as well. Okay, so with a merge sort, we could have some recursive calls in there as we're merging things. But the bottom line is it's much more efficient. Just like a binary search, it's going to give us a lot more efficiency. So we're going to look at a bubble sort, and this is that one we're going to do together. That's an assignment.
Didn't you also say that using recursive calls isn't the best way to go now, since it uses more resources?
Unless that's the right way to solve the problem. So we don't want to use them if there's other ways to solve it. But if there's not, we do.
I
Yeah.
remember I made a recursive method by accident last semester.
Did I get ya?
No,
Okay, so
I
this
didn't.
first one, we're going to do together. I need each of you to take 2 of these. You're going to have an array that is 8 long. We're only going to use 6 entries of that array. So you can ignore your left. So thank you. And then,
So 2 each.
2 each. Now, on yours, I want you to get it kind of set up like this. So I'm going to give you some Post-it notes, little Post-it notes. And we need a Post-it note in each array entry. And then we need 2 more Post-it notes. I want one that says next and has a little arrow pointing up. And another one that says move item and has a little arrow pointing up, and you can abbreviate that to MI or something if it won't fit on these little Post-it notes. So I'm going to give you some, pass them around and kind of share.
Now we're doing this 0 to 5.
0 to 5, yeah, that's all we need. And you can do the same color or different colors, put it out side by side as an array like that one is up there. And then pass those Post-it notes on around. Oh, here's some more.
That is correct. I said no.
You guys can use all those.
Do we need one of each color?
No, just whatever colors you want. I like mine being different colors just to separate them, but they don't need to be. We're not going to do any sort of color coding at all.
Is there pencil sharpener anywhere around here?
Not in here. Yes.
I don't have a pen. I don't have a sharp pencil.
Okay. Like you do. Somebody left that for us.
Someone knew I was going to be in trouble.
You needed it.
Okay, so
Well, it makes
Move item. Now I sort of want the arrows pointing at the top of those because those are going to be our index pointers.
So we need the 6 for the array entries and then 2 more for move up and move down, or what is it?
Next and move item.
Next is the item. Are they both up arrows?
Yes.
Are we doing that on the Post-it notes?
What's that?
Are we doing that on the Post-it notes? Or
What?
the up next or two?
Yeah. So we
All
need
of them?
2.
No, there's just the 2. There's
Just
like
the
8
2.
total.
So what are we writing for the entries inside of the array?
We don't know yet.
That's
That's why we just have empty pieces of paper. Good question. We'll do that. Okay, so Levi's on this. He's like, what are we supposed to write on them? Well, we haven't decided yet. Let's look at this code. This code is what we're going to walk through. And this is an insertion sort. We're going to do our bubble sort together, but for this one, we'll just walk through, do a desk check kind of is what we're going to do. This morning, one of the students was talking about, I guess he had, with the slot machine, I think he was showing his dad used to do software too, and so he was showing his dad his code. He was having some sort of bug, and he found it using the debugger. And he said his dad was like, man, that debugger is really cool. I didn't have anything like that when I used to be a programmer. And so back in the day, we had to do all sorts of things by hand. And every once in a while, it's kind of nice to do that. Even though we could step through it using the debugger, it doesn't quite give us that same hands-on feeling of understanding exactly what's going on.
And then sometimes the debugger doesn't want to show you the values that are being
Yeah, what's changing.
yeah. I had a few issues like that. And it's just like, why aren't you showing me?
Just being mean to you. So this program here, this class is insertion sort. So it's doing an insertion sort. If I look at this class, I see it has some class variables, an array that's going to hold the data. We're going to make ours an integer. This one is a double, but ours is, we're going to pretend it's an integer. And then a random number generator. So it does have instance variables. This is kind of a class where we would have a constructor.
You want us to like make this ourselves?
We're going to make this, we're going to do this now. So in our constructor, when we create an instance of this class, we're asking to be passed a size. So our constructor looks a lot different than the constructors we've done where we've just set class data values, right? In this constructor, we're allocating our array at whatever size was passed to us, and then we're going into a for loop. Now in our for loop, we're setting up to run through our entire array, and we're using our random number generator to generate values between 10 and 100 to load into that array. So that's all that's happening in our constructor. So let's do that ourselves here. What do you want your first number to be? What did that random number generator generate?
10 to 100.
7's fine. We're going to go 0 to 100.
Okay.
So we'll go that way. Okay, what do you want our second number to be? Don't make these in order. Let's go higher. How about higher? 79. Yeah, we want to get some range here. We don't want them in order. You programmers going to put everything in order right in the first place, and then we won't be able to sort anything. 22 next? Okay. Then what?
64.
64?
94. Sorry.
2. Thank you. Then what?
101.
98.
I don't want the biggest one at the end. Thank you. Oh my gosh, you guys are so rigid already putting things in order.
We're beginning programming.
Now, you guys write those same numbers down on yours, because those are our random numbers that we're going to sort. Got them? Okay, so in our sort method, we have a few other variables that I've put up here. First of all, our array is named data. That's its variable name in our code. We have a variable that we're setting up here at the beginning of our sort called insert. So I'm going to write that down here. I want to keep track of that variable. Then in the for loop, we create a variable next that again we're going to be keeping track of. Within that loop, we have our move item variable. And one thing that's really important in our for loop is the length of our array. So we can allocate that. What's the value of our length property for our array? 6. So I'll put that down. Now, as we get started here looking at the for loop, we're going to set the next variable equal to 1. So I'm going to take my pointer and put it under the 1, right? Because that's what its value is right now. Okay, and as I go, well, I'm going to take a look at that for loop now. So I've set up my next variable. My for loop condition says, is the next variable less than your length property? Yes, it is. So I'm going to execute my for loop. First thing in my for loop is set the insert value variable equal to the entry in the data array at this position pointed to by our next variable. So I'm going to set insert to 79. That's the one that we're pointing to with our next variable. The next line of code then declares a variable move item and sets it equal to our next variable. So I'll set it to 1. And now both pointers are pointing to the same entry in our array. So I'm ready to evaluate this while loop. The while loop says, while move item is greater than 0, which it is, and the data at move item minus 1 is greater than insert. It's not. So we're not going to execute that while loop, right? So we're going to drop down out of our while, set our data at move item back to that insert value, which is going to be a net no change to us. And then finally, we would run this print method that we'll take a look at eventually to print out the array right now so we can see it be sorted. That's just a troubleshooting step. Okay, so that was our first execution of our for loop. So now we're going to be back to our for loop again. We're going to increment next. So now next is going to be equal to 2. I'm going to move that pointer over. It's pointing at that second array entry. I'm going to evaluate my condition. Is next less than the length of our array? Yes, it is. So I'm going to execute our for loop. I'm going to set the value of insert, bless you, to equal the value pointed to by our next variable. So insert is going to be 22. Then I'm going to set up move item and set it equal to the value of our next pointer. So now I've got them both pointing to this entry. And we can evaluate our while loop again. This time should be a little more exciting. Last time we didn't do anything. So this time in our while loop, we say, is move item greater than 0? Yes. Is the data at move item minus 1 greater than our insert? Yes. So we're going to execute our while loop. In our while loop, we say the data at move item should be replaced by the data at move item minus 1. So I'm going to set my data and move item kind of over here. And my move item minus 1 is going to move over. Then I'm going to decrement move item. So now it's 1. I'll move it over here. And I'm going to go back to my while loop. In my while loop, I'm going to say, is move item greater than 0? Yes, it is. Is the data at move item minus 1 greater than insert? No. So we're going to drop out of our while loop. And we're going to say, set the entry at move item equal to your insert variable. So now we've got those first 3 kind of in order. We would do our printing of that pass, because notice how we moved some things around. And then we're going to go back to our for loop. So in our for loop, we're going to increment our next pointer. So now it's going to be 3. We're going to evaluate our condition. Is our next pointer less than our length? Yes, it still is. So we're going to execute our for loop. The first thing we're going to do is set our insert value to the data pointed to by our next pointer. We're going to set our move item equal to our next pointer. So now they're both pointing to that one. And then we're going to evaluate our while loop. In our while loop, we say, is move item greater than 0? Yes, it is. Is the data at move item minus 1 greater than insert? Yup, it is. So we're going to execute our while loop. So in our while loop, we're going to say, take that data at move item minus 1 and move it to the position pointed to by move item. Subtract 1 from move item. And it's pointing here. Now, we're going to evaluate our while loop again. Is move item greater than 0? Yes. Is the data at move item minus 1 greater than our insert? No. So we're done with our while loop. We can drop through and set the data at move item equal to our insert variable. And then we would print out that pass. So notice now, the position pointed to by our next pointer, everything preceding that is in order. So far we've gotten those things in order. Everything after it, we don't know, but everything preceding it is in order. Okay, so we're ready to execute our for loop again. So we're going to increase next. And we're going to evaluate our for loop condition. Is next less than the length of our data array? Yes, it is. So we're going to set our insert variable equal to the data pointed to by our next pointer. So it's going to become 79.
I thought next would be 10.
Hmm? Yep.
Okay, I was just making sure I was following along.
No, you're in the right place. I didn't move something. So it should be, where do I want? What do I want?
2.
2? Okay.
Okay, just making sure.
You got it good. And then we want move item to be equal to our next variable. So they should both be pointing at that one. Now we can evaluate our while loop. Our move item is greater than 0. Is the data at move item -1 greater than insert? Yes, it is. So we're going to execute our while loop. In our while loop, again, we're going to set the data at move item -1 into our array at position move item. After we do that, we're going to subtract 1 from move item. And then we're going to reevaluate our while condition. Move item is greater than 0. Is the data at move item -1 greater than our insert value?
Yes.
It is. So we're going to execute our while loop. So in our while loop, we're going to set the data at move item equal to the data at move item -1. And we're going to subtract 1 from move item.
So basically, this is basically the variables that would do the actual array at one point, essentially.
You what?
It's checking the variable instead of checking the array every time. It's checking the array at the position, but only checking it like once in that position versus I'm not getting this right.
No, I think you're getting it right. So let's see. I got to get back to here where I am. Where am I? Okay. So when we look at this one, we said, yes, we are going to execute our loop. So we're going to move our move item -1 data into our move item spot and subtract 1 from move item. Keep going here. Now we're going to reevaluate our while again. Move item is still greater than 0. Is the data at move item -1 greater than our insert value? Yes, it is. So we're going to execute that while loop one last time. We're going to say the data at move item -1 should be moved to the data at move item. We should subtract from move item. And now in our while loop, is move item greater than 0? No. So we are going to fall out of that while loop. And right here, we're going to set our move item value equal to our insert value. So again, we've just completed another pass, and everything from our next pointer down is in order. Good? So we got one more. So for our last execution then, we're going to increment our next variable. We're going to save the data in our insert variable. We're going to set move item equal to our next pointer value. And then we're going to check our while loop. In our while loop, move item is greater than 0. Is the data, oops, I got to move item over here. Is the data at move item -1 greater than insert? Yep, it is. So we've got to execute our loop. So in our while loop, we're going to move those. Oh, put my 36 over here, my 79 here. And we're going to decrement move item. Now we're going to evaluate our while condition again. Move item is greater than 0. Is the data at move item -1 greater than insert?
Which it is.
It is. So we got to execute our loop again. Gonna move this over, subtract 1 from move item. Check again. In our while loop, move item is greater than 0. Is our data at move item -1 greater than insert? No. So now we're done with our while loop, and we're gonna finally, as our last thing, set the data of move item equal to our insert variable.
That was painfully long.
And then we're done. So we can step through every line of code and see exactly what's happening, know exactly what's going on within our array. So that's an insertion sort. With an insertion sort, as we move across the array, we're sorting the values preceding that entry, right? So anything preceding our next pointer we saw was sorted. Well, we want to create a bubble sort. That's the sort we're going to create for our assignment. And a bubble sort is a little bit different. In a bubble sort, we're going to kind of be a little bit less efficient again. We're going to be looking through the array starting at the leftmost position, but we're going to be going all the way across looking for the greatest value. We're going to end up with that greatest value at the top of the array. So it's going to be kind of like that very first one we looked at, where it could be considered inefficient, but yet a bubble sort is not too bad. So let's write one. We got time. I'm going to look at this insertion sort to think about creating our bubble sort. But there's one more video that's super important for us to watch before we do this. This is a selection sort. Here's the insertion sort like we just walked through. Notice how the entries are getting kind of sorted as we go. It's really cool. There's some that are like colors and all sorts of different things, but they're very neat. And I think they really do a good job as kind of giving us a visual of the performance. Now this is a quick sort. This is a Linux sort. You can see it's sort of a merge with other things mixed in. So they merge a little bit, sort a little bit, merge a little bit.
That's so crazy.
Doing stuff. Now this one is a real merge sort. But notice it didn't just split the array in half. It looked at the whole size of the array to decide how many entries it wanted to split off. And then as it merges them, it'll be all done and super fast. Now this is a heap sort. A heap, you know, it's just kind of unordered data. We can see it looks a lot like the bubble sort that we're going to implement, where it's starting at the high end. They're being sucked in. This one is a radix. Now with a radix sort, you kind of set up some buckets and decide how you're going to allocate out the numbers and then sort each of the buckets and then merge them all back together. Super efficient. That's a really good one. Here's another implementation of a radix. There's some different ways that you can do it. Again, they're kind of splitting data up into different buckets and sorting those buckets. Not as efficient as that one before. Now this is a Linux sort. Again, this is a standard sort, a command line sort. So you can, from the new license or whatever, you can see it's pretty efficient. But just like a lot of things in Linux, it's like we can get it almost sorted. Okay, now let's go finish. And I don't know why Linux does things that way. Unix guys. But it looks very efficient. Kind of takes it a bit there to do that final sort. I'm not exactly sure what goes on there with the almost sorted thing. Yeah, and this is another Linux sort. It's doing sort of a merge. Yeah, it does. It seems very efficient. They kind of merge the front half and then merge the back half and then put it all together. So they do sort of get it in half. Super efficient. This is a shell sort. You can see it's sort of a mix between the insertion sort and some of the other types. I'm really curious to know what it's looking for at that last little pass. Now this is a bubble sort. This is the one we're going to increment. Notice how it's moving all the high values to the end of the array. But it's very efficient as it goes.
Looks like it gets faster at the end.
Yeah. There's less to look through. Cocktail shaker sort. This was two guys sitting in a bar with some napkins, right? So they came up with this idea. Yeah. This is a GNOME, a Linux GNOME sort. GNOME. It's a Linux implementation.
What's really interesting about this is to actually do this, they're actually using these sorting methods just to get this done.
This Botanic one is kind of a mixture of the merge. It's doing all sorts of things.
That looks confusing.
Can you imagine that code? Following their code? I don't know. Sometimes going backwards is more efficient. And this is a BOGO sort. So I don't know who created this, but this is kind of like somebody who was mad at Payless or something because this BOGO sort never actually does anything. I guess it's like a buy one, get one sale or something. I don't know. But we could watch it for a really long time, but I swear it never actually sorts any data. It just keeps beeping and moving things around. So it's sort of like a buggy sort. Maybe that's what it should be named instead of BOGO. So yes, again, if you can't sleep, lots of awesome sort videos on YouTube for you.
What was the name of that video?
I searched for sort visualization, and you'll find lots of them. Like I said, there's some colored one, you know, colored-y circles and things. So there's some neat ways to try to visualize it.
With the bubble sort, since it's you're finding the highest value first, it never has to go back.
Yes, but I mean ours never. But ours had to go back because we didn't know we had the lowest. Yeah. So we had to keep backing up. And so I think that our bubble sort, right, it's still.
So we're going to want to do a move next, but like in an odd way.
Yeah, in an odd way. Let's create a project. For this one, we can use a console project. Kind of scary. Yeah. And I'm going to do a .NET framework. And I'm going to name it Bubble Sort 102.
You said .NET framework?
Yeah.
And was it a console application?
Yep, console.
I don't want to ask you, I can just look.
Do I?
I don't want to wear ask.
Oh, that's right. Just look. So my sort is going to be, like I said, kind of a lot like that insertion sort that we looked at, but there's a few things I'd like to do different. So let's see what we can do. We're just going to kind of meander through this and think about it as we go. First of all, I want to add a class file to this project because I want our bubble sort to be a separate class. So let's add a class. And I'm going to name that bubble sort. Now in that insertion sort class that we were looking at, I mentioned that there were instance variables, there were class variables. And in order to run that sort, we had to create an instance of the sort, which is fine. But if we were working with a huge array of 1 million entries, then we would be using up a lot of memory if we had multiple instances of that sort out there. So for our bubble sort, I would like to use static methods. So we're going to make this a static class instead of an instance type class. So that means we can't have any class level variables. So let's think about starting out with our load. That's the first thing that we're going to need. So in our load, I'm going to make it public. And for right now, I'm going to leave out some other keywords and just name this method. And then I'll come back and fix it because it's going to be mad at me. But I'm going to make this be load array. Now, because this is going to be a static method, I'm not going to be able to read the array from our class level variables. I'm going to need it passed to me as a parameter. So I'm going to expect an array of integers to be passed into this method, and I'll call that array toLoad. Now, because I'm going to be working with the array instead of instance variables, I'm not going to have getters and setters. So I'll go ahead and set it up to where I'm going to return an integer array out of this method also. So I'm down to the only error being that I don't have a return statement. So that's pretty good. It's getting there. Now, I don't have the static keyword in yet because I want to leave that out to show you what kind of error we're going to get or what kind of problems we will run into if we leave that out. So in our load, we need to allocate a random number generator. And we don't need to worry about allocating our array because it was already allocated when it was sent to us, right? So we have a pre-allocated array. We can just go straight into a for loop. And we'll make our for loop controlled by an integer named I, and we'll start it at 0. And we'll execute while I is less than what? Yep. So the length of our array. And for every iteration, we're going to add to I. So in our for loop, all we need to do is update the value of our array entry at position I by generating a random number. What do you want your range to be of random numbers? 1 through 7? No, too many duplicates. We need more.
I was just thinking like 1 through 100 or 0 through 100, but 1 would work.
Let's do 1 because 0 messes everything up.
Yeah.
So if we're going to do 1 through 100, we have to say 1 through 101, right? And I know nobody messed that up in their slot machine because you remember that random number generator in C#, you have to go to a digit higher than what you want your highest value to be.
I'm getting an error with the variable for the random number generator. I'm not sure what it is.
Do you see it?
Yes.
Okay, good.
I honestly don't know why I didn't see that.
No problem. All right, so in our load here, after we've got everything loaded into our array, we can return that array and then get rid of that error. So at the end, after our for loop, let's return our toLoad array. Now, I kept mentioning that print pass method in that sort that we were working on. And I said, it just prints out the whole array so that we can see and do some debugging and troubleshooting as we're working on it. So let's go ahead and create that method so that we can print out our loaded array with random numbers and make sure our load worked right. And then we'll come back and do our sort. So after the load array method, I'm going to add another method. This method is going to be void. It doesn't need to return any data. It's just going to print out the array. I'll call it print pass, just like they did. Now, because we don't have instance variables, we're going to need to pass that array into this method. And I'll call it toPrint. And in order to make this printout nice and helpful, we're going to use a couple of other variables too. We're going to require an integer that we'll name pass, which is how many times have we gone through this array. And then we'll have another integer called index. And that'll be kind of where our ending point is so far as we're passing through this array. So for our print pass then, I'm going to kind of grab this code. Do you guys want to put that console keyword before all of these, or do you want to add the using? Let's do it.
Oh, that's why I forgot they had to have static in front of it.
Then we shouldn't have to type that all the time. Okay, so in our print pass, we're going to start out with a write statement. And we're going to write out this helpful message. After pass, what was that? Remember last time, the other day, just the other day, we were looking at that PowerPoint and that way that we could print out variables without having to use those parameters. Do you remember what that's called? I don't.
Can you repeat the question?
The way that we were,
It's both the money sign.
yeah, where we could print things out without having to use those parameters.
I remember you showing this. It's like that really.
Yeah, I can't remember what that term is. I'll bring up that presentation and look. I won't remember it until I can finally remember it. String interpolation. So let's interpolate this output. I got to say it, and I'm not going to. So instead of saying after pass parameter, I'm going to use curly braces and say pass. And then close my write statement. But like Greg said, before our beginning double quote, we have to have a $sign to indicate that we're doing that string interpolation in this string. So the $sign says interpolate this thing, and then the word pass within our curly braces is saying print out this variable right here. So I don't know, I just like it a lot better.
Oh, I see what you're saying. A bit of typing.
Yeah, and it's just clearer because you don't have that weird counting all your variables and stuff. Okay, so we're going to output all of the array elements until we get to the last one that was swapped. Whatever pass we're working on that was sent to us as a parameter, we're going to stop there and do some things in our output. So we're going to try and make this nice. So for this, we're going to start our output using a for loop. And we're going to run while I is less than the value of the index variable that was passed to us. And notice in this one that the increment is a prefix increment. So they have the pluses before the I. And we need to try swapping that around and seeing if it makes a difference. And I don't think it does in this code, but it could in some other code. So for each entry in our array, let's write it out. So we're going to write out our toPrint array at position I plus a space. So this would be kind of a standard way for us to print out an array anyways. But we're going to make it a little bit rougher for this one. That's the end of our first for loop. So after that for loop, we're going to write out an interim message. We're going to write out the entry in our array that was at that position the index is pointing to. Remember, this is where we stopped in our for loop. So we're going to write out that entry now, but we're going to add to it an asterisk and a space. So that asterisk will kind of key to us, this was the entry that was just swapped in the last pass. Then we're going to finish. Because our index position is going to be moving across that array as we change locations. Now we're ready to print the rest of it. So again, we're going to use an integer named I starting at 0. Oops, wrong place. We want I to start at that index location plus 1. And we're going to run while I is less than our array length. And again, we're going to add to I for each iteration. Now in this for loop, we're going to write, just like we did in the first for loop, our to print array entry at position I plus a space.
Wouldn't it be better to do right line so it's not all on one line?
We want it on one line. Now, after that for loop, we do need a \n to get to a new line. Levi's always just right ahead. And that is going to be for alignment. And we're going to see if we like the way this is output. We might need to fix it a little bit. Now, one last thing that's in this code that I'm looking at, and I don't know if we're going to want to keep it or not. We'll decide as we run it. One more for loop, set up with an integer named I, and it's going to run again while I is less than or equal to the pass variable that was sent to us. And in this loop, we're going to write 2 hyphens and 2 spaces. And these are just separator things. You'll see as we run this code what kind of output it's generating so that we can see each pass of this array output. And if you had to do it on your own, you might want to change it a lot. But since you don't have to, we'll just put this in. Now this very last entry in our method, we're going to output another \n. And of course, we can make that a right line, whichever way we want.
Right line would do two.
So that's going to be the end of our method. Now this method is one that you're going to want to kind of keep around. We're going to fix it to make it a little bit better, but it is kind of a standard thing for printing out arrays and doing some debugging and things like that. So how can we test it? Let's go back to our program.cs, and I'd like to rename this. So first, let's rename it. And in our programs that we've been writing, we've been calling this code our tester, right? Our tester code. And you'll see a lot of people call it the controller, because the controller also could be being our tester. And then in a lot of the new textbooks, they're calling it the driver. So for, did you see driver? So for this one, let's call it driver, because I think they actually asked you about a driver on the MTA exam. And I'd like to remember what that is. Yeah, I think controller is a great name. And I stick with tester because it's so hard for those beginning people to understand that this class is testing that other class. But I think that driver is important for us to acknowledge since Microsoft seems to like it. So what do you want to call it? Sort driver? That'll work. Yeah, I like the controller name. To me, that makes the most sense. But
Controller or not controllers, driver just seems a bit vague.
well, I just was a hardware person for too long. So to me, I think of hardware drivers and I'm like, what? Okay, so now we have our driver set up to do our testing. And because we are going to make these static, we'll be able to call them in a little bit different way. But before we do that, we need to allocate an array, because remember our array is going to come from our tester. I'll call it the array. And let's make it like 100 entries. We could make it less for testing, but I like it to have enough that it actually is substantial for us to see some things. Okay, so we've got our array here. I don't think there's anything else we need
Except to call the method.
call the methods. So let's see, we're going to be using our bubble sort. And IntelliSense isn't giving me any methods to use
It's not static.
because it's not static. So let's make them static. So in our bubble sort, we want to add that static keyword to both of our methods. So terminology-wise, by doing that, we've made this a static class. Even though we don't really add that keyword static at all to our class statement, since all of the methods in this class are static, it's in effect a static class. Now if we go back and look at our driver code, we should see that our methods are now available. And we want to do the load array first. Now we were supposed to, in our load array, pass an integer array. So I'll pass the array. Now, if you remember, our load array method returned the updated array to us. So theoretically, we should be setting the array equal to our load, right, and get our output. We're not going to. We're going to just leave it like this and see if we need to, because we're working with arrays. So now I'm going to use our bubble sort to print it, and I want to print the array. Why are you mad at me?
Because we had to separate variables.
Oh, more other things. Okay. So let's just send a 0 and a 0 here, because this is our preliminary pass. We don't really have any index values set yet. So I'll just say this is our first one. So because we made these static methods, we can just call them directly, just like their code in this program, right? As long as we don't need to keep this data separate for different instances, we can use static. So let's run it. Theoretically, we shouldn't get any output because we never saved our returned array that is loaded. So are you getting anything?
No, yeah.
Oh, it's disappearing. We need a read key. And I'll just type the word console because I'm not going to put that using in this one. So we'll just have a little bit. Okay, so why do I have data? How can I have data?
It's in the first instance.
But I didn't capture that returned array. So the reason we have data is we're working within an array. And remember, from your CIS120 class, we can pass data by val or by ref.
And arrays are passed by reference.
Arrays are always passed by reference. So remember, by val is saying, I'm going to take this variable A and make a copy of it, that value, for you to use in your method. By pass by reference, I have this array, and I'm saying, here's the pointer to where that thing starts, the reference into that array, and I'm going to give you that pointer. So now we're both pointing to the same place in memory as we're updating. So we don't need to return that array, right? Because as soon as we update it in our method, it is updated in memory, and since we're pointing to that same place from both of those methods, we don't have to worry about it. Why does C# do that with arrays? That's completely opposite of the way other stuff's passed. Why would we do that?
Doesn't it make it like a little bit easier?
Nope, good reason though. Why would it be? What's a really good reason? Think about arrays. How big are they? Do we really want 57 copies of an array in memory as we're passing it from one method to another? No. So the developers decided early on, with arrays, we will always pass by ref so that we don't make a bunch of copies of it. So it is a performance thing. So let's look at our bubble sort again. That means that for this load array, we don't need to return that integer array. We can make that a void method, and we can get rid of the return statement. Now you guys are going to see different preferences for that. Some people might like for you to go ahead and return that array anyways, even though you don't really need to, just for consistency. I've seen people that really like it coded that way. I don't like it that way because it's confusing. It makes it seem like there's something actually happening there when there isn't. So you could see a lot of different opinions about that.
Wouldn't it also be better to use a return statement because other languages may have you use return statement?
But I'm writing in C#, so I don't care about other languages.
Well, I mean, like if you have knowledge of other language already.
No, I don't care about other languages. We always focus on the language we're using. If we ever looked at what was capable in another language, we would never get good things written in this language. So no, we don't care. We just think about it is consistency. All right, so that was a good learning thing. Notice whenever, that's one reason we had that one adjunct that kept using Visual Basic in the 120 class, because Visual Basic gives you the ability to manually pass by ref or by val so much easier than any of the other languages. And so he continued to use that language because it really emphasizes those differences. Those of us that used Python or one of the C languages in the 120 class, we can't really hardly get a good example of that until we get to arrays. So it'd be a hard thing to understand. Beautiness. All right, so let's look at our output here. I'm going to run it again. Notice that our output is every entry in our array. It starts out with this after pass 0 thing. I think I want it to go to a new line after that, don't you? Because that looks kind of ugly. Yeah, kind of gross. So let's go to our print pass method. And right here, this very first write, I'm going to put a new line at the end of that. And then if I run this again, how could I, this is fine, you know, theoretically, but how could I make it split those numbers up a little better? Like what if I wanted 10 numbers to print and then a new line, and then 10 numbers to print and then a new line? Could I do something easy in this for loop to make that happen?
If I equals 10 new line.
What about when it equals 20?
Wouldn't it be like
That'd be every.
I modulus of 10?
I modulus 10.
Yeah, I was on the right track.
You were.
My instructor did this in one of my classes, so that's why I had that.
Good, good. Okay, so I would write out that new line, and I need to copy that down to this area where we say we're going to finish outputting. I'll copy it, And then I'm going to copy it down to this last for statement that outputs these
You might
dash
also-
dash things.
You might also want to use curly brackets where it's going to execute both of them.
No, it won't. It only does one line if I don't have curly braces. That's when you're going to have to get more clear on for your certification exam because they're going to throw those at you like crazy. Does that look better? What do you think? Do you like 10 or should we do more entries across than 10?
10 is fine.
10 is fine.
We could expand it if we decide 10 is.
Let's do 25. How about 25? Since our array is 100, that would give us like 4 lines. So all I have to do is change that modulus to use 25 instead of 10. Would have been nice to set up a variable for that, huh? And then we should have, that looks good.
That looks better.
Pretty good.
You have 4 lines, what? Oh,
Do you have 4 lines?
yeah, I have 4 lines.
Okay.
I thought I had 3. I was like, what do I have 3 lines?
I bet you are. I was thinking you should have 4. Beautimous. Okay, that looks great. So let's put in our sort. We're gonna run out of time. So let's start it and then we'll finish it next time.
Okay.
So I want to put my sort in the middle, and it doesn't matter where you put your sort method. It's going to be fine wherever it is. To me, it's just logical to have my load, then my sort, and then my print method in that order. And I'm going to make this a void method again because I know my updated array is going to be available. And we'll call this sort. Now for our sort, we're going to need that array of integers to be passed to us. And let's call it to sort. The first thing we need is a place to hold that data that we're working with. So in the last one, the one that we were looking at, that insertion sort, they called it insert. Let's call it bubble because for us, we're doing a bubble sort. So this is the thing that's going to be at our bubble point of where we're moving.
Why do they name it bubble?
They say it's because the data bubbles up to the highest part of the array.
I get that.
They actually have a reason for that
I
one.
was actually thinking like, I was actually thinking before you said that like the brackets indicate like where the index is at. I thought that was like the reference to the bubble. I mean,
Could be. Okay, so let's set up our for loop. In our for loop, we are going to start out using the same variable names as this insertion sort, but we might decide we want to change things. Now I'm going to put this in exactly the way it was in the insertion sort, but we're going to have to swap things around. So if I look at this in my for loop, for our insertion sort, we started at this position because we wanted to compare it to the previous one. For our bubble sort, we really want to start at the beginning and compare it to the next one. So let's set our next variable to start at 0. And then when we get to the end here, we can't really execute all the way to the end of our array, because if we do and we add 1, we'll be exceeding the size of our array. So yeah, we need to stop at sort.length minus 1. But I think incrementing our next variable is going to be okay, because we'll start here, go to here, go to here. So that should be okay going forward in that direction with that variable.
and since it's since we subtracted 1, it'd be the same.
Yeah, it should be okay. So let's then set our bubble variable equal to our to-sort array at our next position. So we'd be saving, the first time through, we'd be saving that very first entry in our array. We'll go ahead and declare an integer move item and set it equal to that next variable. Then our while loop, yeah. And again, I'm going to code this like it is in the insertion sort, and then we're going to have to update it.
Oh, I see why you had it. Yeah, I see why you had an increment afterwards or beforehand.
Beforehand. Okay, so what do we need to change here? First of all, in our while loop, we're saying that, remember, we subtract from move item every time. So we want to run until move item becomes 0. In ours, we've got to swap that around because we're going to be going the other direction. So we want to run while move item is less than our to-sort.length minus 1. Because that's going to be, again, our ending point, that when we get to that end of that array, we want to stop. Now the and part, we need to change a little bit too, because here we're saying, look at the previous entry. We want to look at the next entry. And we don't want to see if it's greater than the one we saved. We want to see if it's less. So we're kind of switching everything around. Like to do, we just need a couple more lines so we can test it. So within our while loop, we're going to update our to-sort array at the item, at our move item position. We're going to set that equal to the data at our to-sort array at move item plus 1. So instead of looking at the previous one, we'll be looking at the next one, moving it over. And then the last thing in our while loop was to decrement the move item, and we need to increment. So we'll make it move item plus plus. That's the end of our while. So after our while is done, we're going to update our to-sort array, position move item. We're going to set that equal to that bubble variable we had saved at the beginning of this pass. Then we're going to call our print pass method. And we need to send it our to-sort array, our next variable, and our move item variable. So we should be ready to test it one time before we go. Let's see what kind of mess we got.
It's not in order.
Do we need to call our sort somewhere?
Oh, right.
Let's put that in our main here. So after we call the print pass to print out the initial values, let's call our sort. We're going to pass the array. And now something should happen.
Oh, wow. That's a lot of stuff.
Yeah, and we got output for 100 passes, right? Because we had 100 entries in our array. And what I want to do is I want to try to scroll up to the first one and look at the difference between the first one and the second one. Because I know my past 0 was that load, so I hadn't really done any sorting then. But if our bubble sort were working properly, we should see that after pass 1, the biggest number in our array, which for me would be one of these 100s, would be at the end. So we've got some work to do, right? Because right now, we just have a backwards insertion sort. You're okay, classes. So we will fix this next time. And then we'll be done with it. So don't worry about getting this one turned in. The one that you're working on your own is the Pig Latin. We'll finish this one up
That's going
together.
to be a pain.
It's not quite there.
Not quite.
It's moving stuff though.
Yeah, stuff's moving. Did it?
However, like, 4 was definitely, from what I can tell, 4 was the lowest that I could find, and it was definitely not 4.
Not that at the beginning.